Calculus. It's Monday after class. Is it snowing as you're watching this? Alright, well, I gave you plenty to do today if it is, so I hope that you're able to use it some for my subject and have the mind and the will to do that. Alright, tonight's lesson is going to come off of what I mentioned at the very end of the last video. So let me put a recap up here for what that was. And that was, well, from the past we knew yn, if y equals ln of x, then y prime was 1 over x. And we knew if y equals ln of u, y prime was 1 over u du dx. So we knew that to be true. So from that I gleaned or made it a logical case for the fact that the integral of 1 over x dx is ln of x, and we kicked it up to include the absolute value. And from here, the integral of du over u, I'll call it that, is ln of the absolute value of u. Oh yeah, plus c, crown it with many crowns. Alright, so let's look at, before I go on and show you how to use that with problems, I want to give you an interesting note. Alright, the interesting note that I want to give you, actually interesting notes, there's 2 of them. And it really won't help you do your problems, but it might help you visualize a little bit more what's going on with some of these ideas. So, first of all, let's look at y equals ln of x, just the graph. And I taught you this in pre-calc, it's a base e. So if I do a sissy chart for 2 values, a 1, let's see, what you raise e to get 1, and e. So if I put those 2 values on my sissy chart, the whole graph should fall into your hands. So this is saying, what exponent do I give e to get 1? And anything raised to the 0 is 1. So the point 1, 0 is on the graph. And this is saying, putting e in for x, what exponent do I give e to get e? And that's 1. So e is approximately 2.7. So I'm going to go over that far, 2.7 and up 1. So if you recall, the tail is down here and it grows slowly like that. So that's the graph. So keep that in mind. And then I want to give you a new definition for ln, and that is an integral. And it turns out that the integral of 1 over t dt, and we're going to go from 1 to x. And x is going to be the upper limit of integration is actually equal to ln of x. So that's kind of an interesting combination of ideas, but it's true. So let's go ahead and see what that means. So we often think of an integral as the area under a curve, and this curve is 1 over x. So I taught you that that's a reciprocal function, and it involved 2 slashes, but we only care for the part, and this is true when x is greater than 1. Sorry, I should have mentioned that. So we only care, when we learned the parent function 1 over x, it was slash slash, but we only care about this when x is greater than 1, because that's when this is equal to this. So this is saying, this is the curve 1 over x, and we call it 1 over t, because this variable is x. So from the area under the curve from 1 to x, so let's say if we pick right there, if we pick right there and call it, say, 3. Say we're just going over to 3. So we're talking about the area under the curve from 1 to 3. So I striped that area there. So we have a pretty good idea that if this x was 3, then that's what it should look like. The area from 1 to 3 under this curve looks like that. But, so that means this is also 3. So this shading in is a picture of the ln of 3. And we already drew the ln of graph, so we were out to, so this is 1, 2, 3. So if I go ahead and graph, this goes across here, about here. If I hit the 3 and go up, you can see that it's a little bit bigger than 1. So there's a connection that the value of this graph at 3 is the same as the integral, or the area under the curve of this graph from 1 to 3. So it's a very interesting connection between things. Oops. Am I running out of battery? I don't know what that means. Okay, I think I'll shut this down and pick it right back up when I can find out what that means. Alright, sorry about that. See you on part 2.